10 minutes are up, so I think we could start. Everybody ready? Okay then. Hello, welcome everybody. It's me, Admios engineer Roberto Subieta, back at another Crypto Thursday. I have another presentation for you people today. Well, first of all, everybody here, I want a few guinea pigs for the experiment we are going to run. So I ask that everybody that has an access to computer right now do this. Hey, hello Luis, happy birthday. Okay. Everybody who is seeing this, please I want some guinea pigs for this. First, I want you to install MetaMask and configure it, and get at least one Rinkebyte testnet ether at that address. We're going to need a few guinea pigs. So, which is today's objective? We are going to run a mock initial coin offering, an ICO. We are going to build a token with for that ICO, and we are going to deploy it to Ethereum, or actually Rinkebyte testnet. And then we are going to modify last week's Greeter contract to use that token, to charge with that token whenever you post something. And here's today's surprise. Please, everybody, please go to that website, and you can see that the ICO is already up, and anybody can stake. This is the website. Right now, uh, when you enter the website, it's going to ask for your MetaMask and your address, and there's only a single button there. Just press that stake one ether, and you're going to be entered in the ICO. Well, first of all, what is an ICO? This thing, many coins, many tokens have require the liquidity to be distributed among as many people as possible. Oh yes, I'm going to share you the link. Yes, now, when many platforms do is that they first ask for people to stake money stake money on the for the platform. So right, in this case, we're going to be staking Ether. With the Ether, they get enough money to start building the platform, or to start building the platform, to get the liquidity for the tokens, and in turn, the platform owner can start paying the engineers to build the app, or paying the server maintenance, or finish up most of the engineering tasks. So right now, this contract is going to give you tokens whenever for each ether you stake. Here, here's the contract I'm building for this. When whenever you stake one ether here, you are you just enter on the you just enter here on this map, and you stake, and I just record how much have you given, and in and that is recorded in this mapping. And then when I am going, and then when our token is complete, I just add it here, and then I mint the tokens. I mint tokens according to how much according to how much ether you have staked. I just iterate through the array, and for each stake, I just mint new tokens for that particular person. And when I finish when I finish executing this function, then everybody who staked will have tokens in their wallet, and they will see it by magic, and they can start exchanging them and using them in the new economy that we have just built. Uh, just for a record, I'm in the contract the contract says that I'm giving you 1,000 tokens per each ether you stake me. So that's what's going to appear on your on your balance. So if somebody else has already staked, that's good. Anybody else? Come on. Meanwhile, I'm going to finish up explaining. Meanwhile, we are going to to build the token itself. So, what exactly is a token? If you go here, if you go to the internet and find the specification, you're going to see that this is a specification that's actually pretty old. It was already created in 2015. Uh, all of the tokens that are on the Ethereum network are compatible with this compatible with this specification. It's essentially an interface. Uh, if your contract fulfills all of the has all of these functions and emits these events, then any other platform can iterate with it, can join it, and can interact with it and use DeFi with it. So the best way to see it is by building something with it. So for example, let's get there. No, this is not a Git repo. So we are going to be building a new contract here that will be that will be our coin. Yes, the second step in order to get Ether, fake Ether, is to go to a faucet and get some Ether at the Rinkeby test network. This staking only works on the Rinkeby test network. So yeah, you have to go to the faucet that I linked already. This is the faucet. I'm going to copy it again. Yeah. Okay. First of all, we have to build a new. First of all, I could write those methods and copy paste them, but um, this is essentially what's called an interface in computer terms. So I could just import it and then implement the methods by myself. So I'm going to install by via npm some abstract contracts, some already built up code that I can use for this exercise. Okay, this is contract code. These are contracts that are already pre-built, and you only have to implement some small details in order for them to be finished. And they include all kinds of standards, and they fulfill all the standards, and they're pre-audited, so it's safe. It's somewhat safe as long as you use them correctly. For example, here we are going to be using in the Open Zeppelin contracts, we are going to be using the here are the ERC20 implementations, and this is the interface I was talking to you about. This is the token standard. This is the exact token standard we saw here in Ethereum's official documentation, but instead implemented as an interface, as an interface. So I will only need to I will only need to implement these methods. But OpenZeppelin already implemented those methods in this other contract. So all I have to do actually is import this pre-built contract, and so I'm just going to call it HappyCoin because I do not have any better ideas right now. Yeah, not. I'm not feeling particularly original right now. Okay, let's go to this preset. Exactly what I am importing. I'm importing an ERC20 token contract that includes just a pauser and a minter. Minter is just another interface that allows me to write coins. And this is the exact contract I'm using in the staking. So this is the way that the stake using the mint is the way is the staker contract is going to be able to give coins to everybody. So all I need is in the constructor. I just need the name for the coin and the symbol. The name of the coin will be the happy coin, and the symbol okay. Yes, I forgot this. That's it. That's the entire coin. But of course, I have to show what's really going on here. Of course. So let's dig in a little deeper. What exactly is an ERC20 coin? This is the ERC. This is the heart of the ERC20 coin. This line number 30, line 34. A mapping is essentially is in programming terms a hash map. So here you have the key is the address, and the value is the value is the balance, the user balance. So each each address that has coins will just have something here that's larger than zero. So what everything the contract does is just for example it's just a small ledger saying address A. If address A wants to give coins to address B, the contract itself, all it has to do is subtract one coin from addresses A balance, and then add one to addresses B. I think that is what is implemented in the transfer. name symbol decimal total supply transfer. Yep, that's what's implemented here. That's the entire heart of the contract. Just sender the sender just the sender just subtracts this balance and adds that balance back to the sender. It's a small ledger. All the rest is just stuff for interoperability between protocols, and how can you read what's happening here, and protection for the users, and all of that. Let me check something else. Does this include the mint? Yes. This is the method we are going to use as in order to create the coins themselves. Um, all the mint does is create tokens from nothing. So this account here, what I'm doing here is that this account this contract will create a number of tokens for this account. So in balances, that account will just receive that amount. This but this method, of course, is protected, so only it can only be called internally, and in the particular preset we are using, uh, only the only the whoever has this minter role can mint new coins, can mint new tokens. So I have first to approve I have to first to approve who's going to create these tokens, and then that contract can create tokens. So that's the main layer. This is the main layer of protection here. Well, as I told you, this is the entire for me to create a new cryptocurrency. This is all that is needed. Just a small, um, less than 10 lines with modern tools. Of course, this library has all kinds of extensions and presets and extra utilities. And oh, this one is useful. This is what one will use for an ICO, really, which is your tokens cannot be the ether you have staked cannot be released before a set amount of time. So this contract, for example, will enforce that. The release only if the timestamp is larger than the predefined time. So this is the good thing about the smart contracts. The code they are designed to be simple to read for coders. The terms and conditions are easy to understand. Okay, now that we have here a contract, let's deploy that contract to Rinkubai the same way we deployed the previous contract, the contract last week, and then I can use it for everybody. So you might have noticed that this is the same project as last week, because well, everything there is already built. So why will I start again? So let's create a new script. That's deploy token, and okay, yes, I remember what I wanted to do. Hmm. Okay, now I copy the old code, paste it here, There you go. Now I yes, that is deployed, but it's deployed locally in my computer. Remember that Hardhat by default uses memory in memory only. So I'm going to have to ask it to deploy to Rinkeby instead. Go. Typo. Okay, I'm going to copy and I'm going to paste that address here in the chat. This will be the final token address. Now, if you go here to your MetaMask, you can press here, add token. There you go, add tokens. Now it appears, the token itself now appears on your MetaMask UI. How much happy coins you have. Of course, right now there's nothing. There are no happy coins created. Uh, have you people been staking here? Only only two people have staked. Come on, people! We need more money. I need more money. I need to buy a mansion. Okay, this is the address for the token. The the way that I have implemented the staking contract is that the stake came first. Then I just had to add this address, and then the contract will mint the coins. Will later mint the coins when I call the second method. So um, for this, there that method is in another repo, so I'm going to have to open it. Okay. First of all, what's going to happen here? This is the contract address we have just deployed. So with this contract address, I'm just taking the staking factory, the contract that's receiving all the stakes you are all right now sending. You're sending them, right? Keep staking. You can stake multiple times. You can press multiple times that button. So each time, whenever what I'm going to do is that and giving that and adding that address here to the token address, and then when that token address is complete, when it's set up here, I'm going to call this method, which is mint tokens. Mint tokens, what we'll do is we'll take the token as a, remember the preset I took on the, I remember the preset I used here on the happy coin. Yes, it's the same preset. I'm going to use that as an object with the address, and then just mint the as, and then I'm just going to mint as an amount for each token, which in this case will be 1,000 tokens for each staked amount. So all I will need to do is to execute this function. Which did I forget the hotkey for this? Yep. Okay. In a real in a real ICO, in a real test, you will have a starting time and an end time, so that people, for example, will know that at what point, at what moment the tokens will be minted, at what point the tokens will be staked. So, all I, but in this case, I'm just going to say that, okay, people, the ICO is over, nobody else can stake, and now I'm just going to execute the contract, execute the mint script. Ready? Let's go. Yeah. Okay, that fixes that bug. Unpredictable gas limit. Yeah, yeah, yeah. This is this one. Yes, because there's a 4 there. You can. Yeah. What happened there is that there's a 4 in mint tokens. So what happens is that staking cannot does not know how much that operation will cost. So I have to give a limit, or otherwise it will burn through all my reserves. Let's try one more time. Hmm. Well, it turned out that I didn't test this function well, so yep. Okay, exactly what happened here. Mm-hmm. I can see that the role was that they granted me. I was granted that role. So that's this. Wait, that's this function. So that it's the other function that's having problems. And this was already completed. Okay, the third time's the charm. Why did it fail the transaction? That's weird. Hmm. Well, that's the cost of me of being too ingenious and trying to do something weird for once. Uh, Normally, what happens in these staking contracts is that the address is given by default here. So what happened here likely is that but no, that's not it. That's not it. That's not the what that is building a new contract. So what went wrong? Set token address. Okay, it failed to set the token address. Oh, yeah. Yep. Sorry about this. I found a problem. I That's the reason why it wasn't it wasn't okay then. It seems like I gave the wrong address, so the address was copied incorrectly. So yeah, I need to find the address again and copy it correctly. Where did I store it? Here. This is the staking stuff. Yes, here. And okay. Yeah, it it was a it was a small incident that I gave the wrong address here to the staking factory. So of course, it was not working correctly. It was going to the wrong contract, the instructions. So let's monitor that over here. Hmm. 0x29 is the 0x29 is the token address. Is that correct? Yes. I think, okay. I think that's going. This is going to be because the two projects have different APIs. So staking. No, no, the staking is the one that has to mint the token. 0x12 is the set to the address is set. So why didn't it mint? Hmm, that's weird. But I just gave you the role. Oh yeah, yeah, I gave the role to the wrong. Yeah, I gave the role to itself when the addresses were incorrect. Remember that I had this. Remember the protection here. Uh, where is that? Yeah, here in the presets in the minter. Remember that I had that they have to give this error that I have to have the mint role in order for me to mint. But since I gave the wrong address, then I did not have the correct the address did not have the correct role. So of course it failed. And how did I find that out? Here here I have the here I have the error code, the same error code that it's here. So yeah, it failed again. Role was granted. Okay, the role was granted. So and the address was set. Why are you okay? Out of gas. Yep, I wasn't paying enough. Okay, last attempt. If this doesn't work, then I'm going to have to do it by in the script itself. That was it. I just had to add more gas. Yeah, it worked. It was the gas. So everybody who had staked, the people who had staked should now see on their MetaMasks their tokens. Do you see them? You will get exactly 1,000 tokens for each ether you staked in this contract. So well, that's it. We have our own cryptocurrency and we can send it to everybody else. But it's not particularly useful right now. It's just these are just not these are just a ledger in the RC in the ERC20 contract. So what can we do with this token? Well, what can we do with this token? If you remember, last week we had this greeter. That this is a contract that just that takes the that just that has a message stored on the blockchain, and anybody can change it, and anybody can write to it. So what we're going to do is that in order to change the message, you now have to pay one token. Let's charge people to change the message in our contract. So I'm going just to put this here, and the okay. The relevant code here is I'm going to have to copy paste a little more than I wanted because this took too long to fix. So yeah. We are going to make a new greeter for example. So excuse me if I have to paste a lot more than I wanted, but I have to finish the presentation. This will be the new greeter. You might have remembered that that we had a boolean here that paused, that whenever the user that we could that we will set that boolean in order for the contract to stop working. Now we are going to be using this small abstract which does exactly that. Just execute pause whenever somebody switches the pause. And also, for example, we are going to be doing the same for the ownable, which is essentially that whenever this contract is built, it just records who's the owner, and then allows me that, for example, only the owner can do certain stuff. So in this case, only the owner can switch the pause, and only the owner can withdraw the tokens. Only the owner. Here is what happens when what I told you about. When you build this greeter, when you build this contract, we are going to add the token address directly, and that token address is going to be saved. Whenever somebody tries to change the message, this contract will go to the token and transfer the fee from the sender to the contract itself. The fee is, right now I had it as 1 ether. Yes, I'm going to have to explain that. Okay, you might have noticed that all of these numbers are UINs, unsigned ints 256. In Solidity, there are no floats. There's no way to define a fraction. There's no way to define a value that is less than 1. So what do we do? So what do we do with this stuff with tokens? We just give them a lot of zeros. In this case, we give them 18 zeros. The real 1 ether is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's 18 way. One way equals 1 to the 1 times 10 to the minus 18 ether. That number is too complicated to remember, so I just use this. But the thing here is that instead of deploying for fractions, the standard is to use 18 zeros in order to be able to represent extremely small numbers as in a single way. That's the reason, for example, that in the last that's in the last week we were using we were seeing huge numbers in the balance. Because, well, in short, we are going to be doing a single we're going to be doing a single ether for the fee. And then we also have to do this because the contract itself is the one who owns the tokens at this point. So whenever the owner whenever the owner wants to withdraw, they the contract itself will take this entire balance and transfer the balance to the owner, and then emit a small event for that. Otherwise, otherwise the funds will be locked in this contract forever and they cannot be recovered. This function is important. Finally, here in the front end, we have to change a few small things here in the front end, because especially because we now have to take in consideration that the user has that we have to allow the user to pay us. So yes, yeah, comment. Yeah, okay. And finally, I need the token address. That's which was the address? It's here. Okay, what changed here? First of all, I'm also making the same way I'm instantiating the contract for the greeter. I'm also instantiating the contract for the token. And then also I'm reading the balance. This is a standard. This is a standard method. One of the standard methods in the contract. Remember that the token contract has certain standard certain function that it has to have. This balance of is one of them. Just takes the address of the current address of the current address of the current address in MetaMask and just asks the contract what is its current balance. What else? Yes. Okay, this is the second part. Uh, there's one thing here in the greeter that that it's not very this that happens here is that the way this seems to matter is that seems to occur is that any contract can transfer funds from any account, but that will be a huge security issue by itself because then anybody can take money from other people. So instead, these tokens force you to approve first. The account owner, the one who owns the token, first has to approve that if you're not going to be the one transferring the tokens, you have to approve who is the one who is going to be transferring the tokens before that that third party can transfer tokens to itself. So that is another standard method on the tokens that first you have to that you are approving that approving the greeter, allowing the greeter to spend some of your money. In this case, I'm approving here for the exactly just the amount of the fee. If the fee has first I query how much I'm allow right now the contract is allowing that the greeter to extract, and if the fee is greater or equal, then I have to do a second transaction here first. The I have to approve the transaction before it happens. Well, the final thing here is that balance and tokens. You remember what I said about that Ether is measured in 18 zeros, actually. This is a small function that takes the current balance and just transforms it into a readable number. So the balance and the token balance both will appear here as readable numbers instead of 18 zeros. So first, I have to deploy this first. Oh, and also before deploying, here I have remember that I changed the signature here. Damn, I forgot the token address. This is the new token address, the happy coin. Just adding the address itself to the contract factory so that it can generate the interface with token. There. And now the new greeter, I can add it directly to the index. No. What was it? Front end. There. Let's test that everything works. Something happened here. Hmm. Okay, what went wrong here? Let's see if this typing works. Is the address a mistake? I'm going to have to okay, I'm going to have to split this. There. It was a bug. Sorry about that. Uh, well, now you can see that my tokens are appearing in the same grid as before. And if I want, there is nothing yet as a starting message and no events. If I want just to write something, let's see, paint test. It should ask for two transactions. Uh, Transaction fee. There's a small transaction fee because of the ether. 10 cents is going to cost me. The first approval. Again, the gas limit. There's the second transaction. Hmm. Well, what happened now? Transfer amount exceeds allowance. Yeah, it prevented me from doing this. It prevented me because I did not approve enough money. So maybe if I try a third time, by itself it will work. But it's weird. Greater than or equal. It shouldn't do that. Oh well. I have to stop here because this is my hour. The hour has ended, so I could not finish the demo. But in short, this method was going to charge me one token for paying for writing this message into the contract. So um, this code is that I have to add more approval money, but at this point, I think I think that well, who wants tokens? Who wants happy coins? Give the first one to give me an address gets 1,000 coins. Okay, Maximiliano, you get 1,000 extra coins just to make sure that the tokens work correctly. There you go. You should have already received it. But that was today's presentation. Sorry I could not finish it. I did not expect to have so many technical issues, but well, it happens. Always happens with live coding. I'm open for questions. Anybody has a question? No questions. Well then, I think we can give this. Okay, I think we can just let this be over. And well, thank you for being with me for I think it was 3 weeks for all of these presentations. And well, thank you for everything. Yes. Now you know how to run your own ICO. The only issue here is how you want your what's called the tokenomics, as in what you want to incentivize with your token. For say, you want the people that receive the tokens, for example, to be in the sticker list, or you want, for example, to add add an address, and then everybody in that address gets 1,000 tokens. More important than the technical implementation, and more important than the technical part is the economic part. We what you want to incentivize, what you want to do with the token itself. That's something an economist might something that has a background in finance can maybe able to tell you better. Well then, I think, well, yeah. Do I close this, or any questions, or well, goodbye, people. Okay.